Now let's look at some special type of relations. They are called as functions. A function is also a relation. So we know what a relation is, isn't it? A relation is nothing but subset of the Cartesian product. If we have two sets A and B, if I apply the Cartesian product, then we are going to get set of all ordered pairs. Now if we take a subset of the set of all ordered pairs, then that is called a relation. Then some of the relations will qualify to become a function if they have some particular characteristics, right, or properties. Let's see what that property is. Simple. See this, a relation, it is important. See this, a relation F. So the definition itself is saying that a function is a relation with a special property. That's it. A relation F from a set capital A to a set capital B is called a function if to each element small a belongs to capital A, we can assign an unique element of B. Right? So what is the meaning of it is, watch it. Now if we have a set like this, capital A, which is having, let's say, 4 elements A, B, C, D, and you have one set capital B which is having, let's say, 5 elements 1, 2, 3, 4, 5. Right? Now what is a function is, for every element in capital A you should exactly assign one element to capital B. That will be a function, right? So this will be a function, right? So how do you look at it? It is nothing but a relation. So if you want to look at it as a relation which is nothing but a set of ordered pairs, you can look at it this way. A is mapped to 1, B is mapped to 2, C is mapped to 3, and D is mapped to 4. Simple. Got it? Okay. Now if you try to, what will not qualify as a function is if you don't have this, right? If D is not being assigned to any of this, which means if you don't have this ordered pair, then this relation cannot be a function, because every element in A should get exactly one element in B, right? Or what will not be a function is if you have, let us say you have this also, which means you have D comma 4 as well in this. Along with this, if you have like this, which means if A is related to more than one element, if you have A comma 2 as well, right, then also it will fail to be a function. So if a relation has to become a function, it has to satisfy exactly one property. What is it? Every element in A, if the relation is from A to B, okay, every element in A should get exactly one element in B. That is also called as image, right? So image of A in B, right? So in this case, image of A in B is 1, image of B is 2, image of C is 3, image of D is 4, right? So if you have that, that is called as the function, and you need not have a pre-image for every element in B, which means there is no requirement that every element in B has to be mapped to D. Now you tell me whether these are functions or not. Okay, let us say I have A, B, C, this is A and this is B, and I have 1, 2, 3. A is mapped to 1, B is mapped to 1, C is mapped to 1. Is this a function or not? It is a function, because every element is mapped to exactly one element there, but we need not care whether they are all mapped to the same element or not. So it is definitely a function. Now tell me whether this is a function or not. A, B, C, 1, 2, 3. Is this a function? It is not a function, right? Why? Because A is having more than one image, right? Tell me whether this is a function or not. A, B, C, 1, 2, 3. That's it. Is that a function? It is not a function. The reason is the element C of A is not having any image. Every element in A should have an image, but since it is not having an image, it is not a function. Got it? Tell me whether this is a function or not. A, B, C, 1, 2, 3. This is a function because every element is having an image there, right? So that is how we define the function. Got it? See, a relation. Why? Because it is containing ordered pairs. If you see this, it is exactly looking like a relation. A relation from set A to set B is called a function if to each element A belongs to A, we can assign an unique element of B, which means for every element here we are able to assign an element from B. It is denoted as f is a function from A to B. You have to read it like this: f is a function from A to B, and this particular set A is called as domain, and this set B is called as codomain. In this case, A is domain and B is codomain. A is domain and B is codomain, right? Now we are defining even range. So what is range is, if you see any of these mappings, it is not always necessary that we map every element in B is going to get an element in A, but every element in A is going to get an element in B, but it is not necessary that every element in B is going to participate in the function, right? So if that is the case, see this, these two elements are not present in the function, therefore whatever elements are participating in the function, they are called as range. So in this case, range equal to 1, right? And in this case, let's say D is mapped to 4. In this case, range is equal to 1, 2, 3, 4. Range is nothing but set of all elements of B which are participating in the function, right? So in this case, it is not a function. It is not a function. We don't talk about it. In this case, the range equal to 1, 2, 3 is equal to codomain itself. So if you observe it, if you look at the codomain set, all the elements might not be participating in the function. Therefore, what we can say is codomain is always a subset of range. Range is always a subset of codomain, which means in this case, see this 1, 2, 3, 4 is a subset of 1, 2, 3, 4, 5. Therefore, there is no requirement that every element of B should participate in the function, and so when you write out the range, you will not get all the elements of the codomain. That is why range is always a subset of codomain. Remember that point, okay? And sometimes what happens is, we might define a function from the set to itself, just exactly how we did with the relations. From we have defined the relation on a set, not on two sets. Similarly, we can define functions also on one set only. In that case, it is called as a function on A itself, right? Let's see some questions on this. You will understand even more.
Hi, if you are planning to do masters, then doing masters abroad is better than doing masters in India. I'll give you all the reasons. So, first reason is, out of 1 lakh students who take GATE every year, there are only 500 seats in old IITs. So all the IITs put together have an acceptance rate of 0.5%, and IITs, universities better than IITs, they have very good acceptance rate like 30%, 40%, but all the IITs put together have an acceptance rate of 0.5%. And if you are working hard to get into IIT Bombay's ranking is 177 and IIT Roorkee's ranking is 400. If you are happy to get into IIT Roorkee, then getting into universities better than IIT Roorkee is easier compared to getting into IIT Roorkee. And looking at the salaries for computer science, for software jobs, if you have done your masters in computer science in US, the salaries are ranging from 80 lakhs per year to 1.2 crore per year. So even if you take an average of 1 crore per year, your savings will be much higher than the salaries in India. After taxes and your cost of living, you can easily save 40 to 50 lakhs per year. And in India, the maximum jobs that you get is around 30 lakhs. So your savings will be much greater than the salaries in India. And these are all the services that we provide. University shortlisting. So depending on your profile, we will shortlist what are the universities that you have to apply, and statement of purpose building, and then LOR guidance, and GRE and English test assistance, and education loan assistance. So you don't have to have any collateral, which means without any security, now you can get education loan. Getting education loan is very simple these days, and whatever the amount of fee that you have a range of universities. You can apply for 10 lakh universities, 20 lakh universities, or 50 lakh universities. But whatever it is, you are going to get complete education loan, and you can pay off your education loan in 1 year after you get a job. And then we do visa assistance, mock visa interviews, and then connecting with the university alumni. So now you might ask why we should join Game of Visas. So the answer is we have 90% success rate, 99% success rate. And these are all the destinations that we guide the students to. So we guide students to any country that you want to go. So now it is not just USA. We guide to UK, Germany, Australia, Canada. So we guide students to all the countries. We work with all the destinations. And if you are interested in going abroad, you have to just drop us a message on this WhatsApp number 9494 555 454. Okay, thank you.